Hello everybody and welcome to another C++ tutorial for beginners. Now in this video, I'm going to be showing you the logical operators in C++. Those include and, or, and not. So with that said, let's dive into the video. So in the previous video, I showed you something called comparison operators. Now, when we use these operators in an expression, they return to us a Boolean value, so true or false. Now, what I'm going to show you here is what's called the logical operators. Now, the logical operators are used with combinations of multiple Boolean values to determine another Boolean value. So what I mean by this is we are going to have a logical operator in between two operands that are both Boolean values, and then that logical operator or the expression that uses that operator will return to us another Boolean value. Now, this doesn't seem to make any sense right now because I haven't showed you the operators yet, but the three logical operators that are in pretty much every programming language are not, and, which is represented by two ampersands in C++, and then we have or, which is represented by two pipes. The pipes are right beside, I believe this is the backslash. It's either the forward slash or the backslash. Sorry, this is the forward slash here, right above the enter key. And the ampersands, just look at my keyboard, that is Shift 7. That's how you access these right here. Then obviously the exclamation point, everyone knows where that is, right above the 1. So these are the three logical operators. Now, I'm just going to go through them one at a time. They're pretty straightforward, but what the not operator does is negate a Boolean value or negate an expression. When I say negate, I just mean reverse it. So let me just show you what I mean. If I say like bool x equals, and then I say not true, what this is actually going to be equal to is false, because the not takes whatever is on the right-hand side of it and just flips it. So if it's true, it makes it false. If it's false, it makes it true. That's all the not does. Now you may be asking, why would I use a not? Well, the reason you would use a not is because a lot of times you have very complex Boolean expressions with a ton of different conditions or a ton of different things that you're checking. And it's oftentimes simpler to represent something using a not symbol or to check if something is not true, like the entire thing is not true, rather than rewrite the expression in another way that doesn't involve not. Now, I'll show you an example of this later on, but not is very useful. You're going to see this all the time, and just understand the exclamation point is not. Whatever's on the right-hand side of it, it just flips it. So if I had something like not 1 less than 2, well, 1 less than 2 is going to give me a Boolean value, right? It's going to give me true. So then I have the not, so that would make this whole thing here false. So that is not. Now, I'm not going to really compile the program when I show you all of these, at least right now, because it just wastes time and I don't really need to do that. But now let's move over to the and. So the and works in the following way. You have two operands, right? You have a left operand and a right operand. So I can say something like bool y is equal to, and I'll say true and false. Now what the and does is it tells you if both the left and the right-hand side, or the left and right operand, are both equal to true. So the only situation where and returns true to you is if both the left and the right are true. In any other scenario, you're going to get false. So when you have true and false, well, these are both not true. And so this entire expression here, y, is going to be equal to false. Now, if you have false and false, well, neither of these are true. Both of them are not true, and so it returns false. If you have false and true, this returns false because there's a false right here. Both of these need to be true to return true. But finally, when you have true and true, this returns true. So this is just another logical operator. Next, we have the or. So I'll say bool z is equal to, and then true, or, and then false. Now what the or does is it tells you if either the left or the right-hand side is equal to true. These are fairly intuitive. Their names make a lot of sense. But if either the left operand or the right operand, or both of them are equal to true, then it returns true. So we could say true and true, that returns true. True and false, that returns true. We'll leave a false there and change this to false. This is going to return false now because both of these are false. But now if we have false or, and then true, that returns true. So those are the three logical operators. Now let me show you a few examples of kind of using these with each other. So let's try an example. Let me just actually erase all of this. I'll just say bool test is equal to, and just this is going to be kind of a quiz for yourself. You can try to tell me what you think it's going to return. So if I have not and then false and true, what is this going to return? Or what is test going to be equal to after we evaluate this expression? So take a second to think about it. I'm about to tell you the answer right now. Well, we can walk through this, right? So if we see false and true, we have to figure out what this is going to give us. Now, false and true is going to give us false because we don't have true on both sides of the and so that returns false. But then right here, this whole thing becomes false, and then we have a not. So since we have a not, and we are notting this expression right here, which we know to be equal to false, test is going to be equal to true because we are kind of reversing this, right? We're negating whatever the value was. So now let's do another example. What if I have not false and not true? What is this going to give me? Well, this is pretty intuitive and straightforward. When you have not false, that's going to turn this to a true. Then you have not true, that's going to turn this to a false. And so you'll have true and false. Obviously, the and here, well, they're not both true, so it's going to give us false. And so test is going to be equal to false. How about when I change it to this, though? I change it to an or sign. So not false or not true. Is this going to return true? Well, it is going to be equal to true. The reason it will be equal to true is because this will turn to a true, and then we'll have true or, and then this will turn to a false. Since we have at least one of the operands equal to true, then this entire expression here returns true. So these were kind of some easier examples, but now let's combine them together. So now let's put a not right here. So we have not, and then not, and then not, and then these signs here. And then I'll even add an and we will and a true like that. So now what is this going to return? Well, this requires a bit more work, but we can go inside of here and see what this is going to return false, or not false, sorry, what it's going to return. First, we see that this expression here will be true. Then we're going to negate it to be equal to false. And then we have false and true. And obviously, well, that is going to be equal to false. So we're going to get false. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and this series, which is Algo Expert. Algo Expert is the best platform to use when preparing for your software engineering coding interviews. I work at Algo Expert as an algorithms instructor, and it is the platform that I use to get a job offer from Microsoft and from Shopify. With that said, check out Algo Expert from the link in the description and use the code TechWithTim for a discount on the platform. Now, I want to show you a little trick here because a lot of times you'll see that you're writing these like really complicated Boolean expressions. These are what they're called, Boolean expressions, when you have logical operators separating different Boolean values or conditions or whatever you want to call it. And anyways, there's a way that we can simplify this. So whenever you see a not symbol here, what you can actually do, if you don't want to kind of do all of the evaluation yourself and you want to simplify the expression potentially, depending on what you have, is you can apply this not to both of the operands, so both the left and the right operand, and you can flip the logical operator here from or to and from and to or. So this is a rule that you would learn in probably 1st or 2nd year university in Boolean algebra. I believe that's when they teach this. But the idea is that when you have a not and it's surrounding an expression, so we're surrounding an expression that has a logical operator in it, right? And it's being applied to the whole thing. What you do is you take this and you apply it to both the left and the right operand, and then you swap this sign to the opposite one. So what this would look like is we take this not and we apply it to false. So what that means is we're going to get not false, and then we're going to apply it to true as well, and we're going to get not true. And then we're going to switch this sign. This sign is now going to be equal to an and because we need to flip it. And now we can look at this expression right here. Now, two nots, well, not false is going to be equal to false, right? We kind of negate the not. So whenever you have two nots, they really just cancel out. So we'll cancel them out. And then whenever we have two nots, they cancel out here. So this is going to cancel out. So now we just get false and true. We see that this is equal to false. And so we get false. Now that is the exact same as this, right? If you go ahead and do this, we're going to get true. And then we're going to negate it, and we're going to get false. So whatever you kind of prefer to do, but a lot of the times I like to take my nots and kind of bring them inside of the expression just because it can clean it up quite a bit. Now, to show you one more example here, let's try something even more complicated. So let's say false or not true, or, and then we'll just have a not true here, and then I'll say and true like that. Okay, so now we're looking at this expression, a little bit more complicated, but I'm going to show you first of all how we can simplify this and then how we can evaluate it. So this applying the not to the left and right operand still applies even when you have a more complex expression. So in this case, we have our or, right? And then we have the left operand, which is this entire thing in parentheses, and the right operand, which is this right here, the not true. So we can do the same thing. We can now bring our not in. So I'm going to apply the not to now, oops, didn't mean to do that, this entire left operand, and I'm going to apply it to this right operand. So we'll start with the right operand. We'll see that this is just going to cancel out because two nots, well, those cancel each other out. And now we have a not in front of another expression. This expression has a Boolean operator inside of it. What we need to do is bring the not in. And also, I just remembered we need to flip this sign to be an and. My apologies, I just forgot to do that. So now we take this not and we're going to apply it in here now. So now when we apply this not, we're going to get not false. And then we're going to switch this sign to an and then we're going to have not true. So not false obviously is equal to true. And let me just remove this not here because we've already kind of brought that in. So not false is equal to true. Not true is equal to true. And so what we get now is true and true. So true and true is going to be equal to true. And then we have true and true. This is going to be equal to true. And then we have true and true. This is going to be equal to true. And so we would get true. So I would recommend you guys do a few of these kind of little quizzes or exercises for yourself. Just write out some expressions that have both and ors in them and nots as well. And see, first of all, if you can simplify them the way that I just showed you here with that little trick. And then if you can determine what the value is actually going to be. Now, I know this seems very theoretical right now, but I will show you in the next video when we get into if, else, and else if statements why this is very important. Because a lot of times you want to use a combination of kind of conditions or checks to determine if you should do something, if your program should do something. And actually, just to end off here, what I want to show you is that you can have comparison operators and use those with logical operators. So if I have something like, as I showed you before, let's say we have int x equals 0, and then we have int y equals 2. Well, what I can do is something like x less than y, or we can say y equal to x, right? Now, it doesn't really make sense for us to do something precisely like this, but we can write expressions like this. Now, because this is going to return to us true or false, and because this is going to return to us true or false, it's totally fine to have the or in between. It will then look at both of the expressions we've written here and kind of do the or of them, right? So this is where it gets very interesting. That's another reason we have these operators. We don't usually use them with just standard true and false written there. We usually write something like this, which you may refer to as a condition sometimes, or just some expression that uses a comparison operator. So hopefully that's clear. But yes, please do mess around with this, practice a little bit, and in the next few videos, this will be a lot more clear. So with that said, I'm going to conclude video 7 in this C++ tutorial series. I hope you enjoyed. If you did, make sure you leave a like, subscribe to the channel, and I will see you in another YouTube video.